Hi friends, good morning. Today we are going to discuss how to represent gradient, curl and Laplacian operator. Okay, gradient is del f and curl is del cross f and divergent is del dot f and Laplacian is del square. Okay. These operators, we have discussed about these operators. Okay, see these operators we can represent in cylindrical and spherical polar coordinates. Okay, these are very important when we do problems in electrodynamics. Okay, so how can we represent the gradient of gradient, curl and dive and Laplacian of a function using cylindrical and spherical polar coordinate. Before coming to that, we can see what are the scale factors. This is very important term. Scale factors in spherical polar coordinates and scale factors in cylindrical coordinate. Okay, what is scale factors? See, we have studied the length element we can represent in spherical polar coordinate, that is dl is equal to what we have studied, dr r cap plus r d theta theta cap plus r sin theta, right, r sin theta d phi cap d phi cap. So this we have studied in my I think the fourth lectures of this series. Okay, so this we have studied. The scale factors means what is the coefficient of dr r cap, what is the coefficient of d theta theta cap, what is the coefficient of d phi cap. Okay, so coefficient of dr r cap is 1. Okay, that is 1, that is h1, and coefficient of d theta theta cap, that is r, that is h2, and coefficient of d phi cap, that is r sin theta, right? So we defined scale factors. Okay, it is the coefficient of length element in which dr r cap, d theta theta cap and d phi cap. Okay, so h1 h2 h3 that you have to by heart, that is h1 h2 h3 is 1 r sin theta. Okay, and scale factors in cylindrical polar coordinates. Okay, that is here also we studied the length element. Okay, so here we studied the length element as dl is equal to dr r cap plus r d phi cap, r d phi cap plus dz z cap. Okay, so here dr r cap coefficient is 1 and d phi coefficient is d phi coefficient is d phi cap coefficient is, that is r, and dz z cap coefficient is again 1. Okay, so h1 h2 h3 is 1 r1. Okay, so in spherical polar coordinate h1 h2 h3 is 1 r sin theta, and in cylindrical polar coordinate it is 1 r1. Once you know this, we can easily calculate using formulas the spherical and cylindrical polar coordinate expression of gradient, curl, divergent and Laplacian operator. Okay, now let us go to that. See, this is the general expression that you have to by heart to find. So from once you know this general expression, you can convert it into cylindrical and spherical by applying suitable scale factors. So if h1, h2 and h3 are the scale factors in a coordinate system, and q1, q2, q3 are the coordinates, like if you choose spherical polar coordinate, then q1 is r and q2 is theta and q3 is phi. We know that the spherical polar coordinates are, suppose if you select q1 Okay, if you select spherical gradient representation of spherical polar coordinates, then you can take a q1 is equal to r, q2 is equal to theta, and q3 is equal to phi. And also we have studied h1 is equal to, so what is q1 cap? That is r cap. What is q2 cap? That is theta cap. What is q3 cap? That is phi cap. Okay, so similarly you can replace, and this h1, h2, h3 scale factors we have already discussed. h1, h2, h3 in spherical polar coordinate is, that is 1 r sin theta. Okay, now you can substitute, once you know this formula, you can substitute these values here, and then you will get the expression for gradient. Okay, so that's the way. And so for a spherical polar coordinate and cylindrical coordinate, you can replace this. Okay, now similarly we can do this. After this general expression, we will derive it the same for cylindrical coordinate and spherical polar coordinate. Now general expression for divergence, div v is equal to 1 by h1 h2 h3 into dou by dou q1 of h2 h3 v1 and dou by dou q2 h1 h3 v2 and dou by dou q3 of h1 h2 v3. So here we have a pattern. You have to remember the pattern is repeating. What pattern is that is repeating here, then you can easily memorize this. Okay, so h1 h2 h3 value we know. For a spherical polar coordinate, h1 is 1 and h2 is r and h3 is r sin theta. q1 is r. Okay, here q1 is r, q2 is theta, and q3 is phi. That is spherical polar coordinates. So we can substitute here and you can find div v. Okay, similarly general expression for del cross v is equal to 1 by h1 h2 h3 h1 q1 cap plus h2 q2 cap plus h3 q3 cap, and here dou by dou q1, dou by dou q2, and dou by dou q3, and h1 v1 plus h1 v1 h2 v2 h3 v3. Okay, so this is the expression for del cross v. And similarly we have an expression for del square. Okay, then we can derive it for spherical polar coordinate. How can we convert this? And del square is 1 by h1 h2 h3 dou by dou q1 h2 h3 by h1. Okay, dou by dou q1. So study this pattern. Okay, a pattern is repeating here. Dou by dou q2 h1 h3 by h2 dou by dou q2 plus dou by dou q3 of h1 h2 by h3 dou by dou q3. Okay, so this is the Laplacian operator. So these are the four expression we have to remember to convert to form the expression for gradient, divergence, curl, and Laplacian in spherical and cylindrical coordinates. Okay, now if you choose the spherical polar coordinate, okay, let us, how this will convert, how gradient will convert. Let us, so del is equal to, again write this here. See, del is equal to, so first we can check del. Del is equal to, what is q1 cap? That is r cap. q1 is r and q2 is theta. These are the spherical polar coordinate. q3 is equal to phi. So I can write this as r cap, right? What is h1? h1 is 1. Okay, 1 r sin theta dou by dou r. Okay, plus what is q2? That is theta cap in divided by r. h2 is r into dou by dou theta, plus what is this? q3, that is phi cap. Okay, by what is h3? r sin theta into dou by what is q3? Dou phi, right? So this is the expression for gradient in spherical polar coordinate. Now for the cylindrical coordinate, how can you write this? For cylindrical coordinate, del, there q1 is, let he q1 is equal to r or rho. Sometime we will represent as rho, sometime we will represent radius. You can write this rho letter also. Okay, q1 is equal to, q1 is rho, q2 is equal to phi, and q3 is equal to, that is z, right? q3 is equal to z. These are the coordinates. Okay, so this I can convert as, so del is equal to, del I can write, that is rho cap, this h1 is 1, that is dou by dou rho. Okay, dou rho plus what is q2, q2 is phi cap, so phi cap, and h2 is r, right? So rho, h2 phi cap by rho into dou by what is q2, dou phi, plus, and what is q3 cap, q3 cap is z cap, right? That is z by what is h3, h3 is again 1, that is dou by dou z. Okay, so this is the expression for gradient in cylindrical coordinate. Okay, so this way we can replace the h1, h2, h3 values for the so I am not substituting all the values, we have all the values here. Okay, that you can just substitute only. Okay, so look here, to find div v, okay, for spherical polar coordinate, h1 is 1, h2 is r, and h3 is r sin theta. Substitute here. Okay, and h2 and h3 you can substitute here. Okay, and v1 is the term which is available there. So v is a function of v1 I cap plus v2 j cap plus v3 k cap, right? So v I can take as v1, v2 and v3. Okay, so that is the coefficient of I cap, j cap and k cap in the v expression. Okay, so v1, the remaining all you know you can substitute here. Okay, similarly del cross v also you can substitute h1, h2, h3 based on that. So let us go to the final result. Okay, Laplacian also we have. So for a spherical polar coordinate, you can the del f is like this, and div v, that is see 1 by r square into dou by r square vr dou r, 1 by r sin theta dou by v theta sin theta. Here vr, v theta and v phi, that is the component vectors. Okay, v that is given in terms of a radial part, a theta part and a phi part. So that 3 components in v, and remaining all you can substitute like this. Okay, so here h1, h2, h3 you can substitute. Okay, so we can substitute. So let us have a substitution here. Okay, see 1 by what is in spherical polar coordinate, what is h1, that is 1 into r sin theta. What is dou by, what is q1, q1 is dou by dou r of what is h2, h3, that is r into r sin theta, that is r square sin square theta into v1. Okay, so that is so this sin square theta we have, h2, h3 is not sin square theta, r square sin theta. So I can, this r square I can keep here, and I can this sin theta and sin theta I can cancel. Okay, so dou by dou q2, here I can substitute dou by dou q2 of h1, h3, v2. Then how I can substitute that? Dou by dou theta, right? Dou by dou theta r theta phi. So what is h1, h3? 1 into r, that is r v2. Okay, plus what is dou by dou k3? Dou by dou phi. What is h1, h2? h1, h2 is this is common, right? This is common, h1, h3. Okay, now what is h1, h3? h1, h2 is again r. Okay, that is r v3. Okay, so this all about the substitution, h1, h3, h1, h3, here h2, h3. Okay, so here I think there is a h2, h3. So here we have q1, so here q2, so we have h1, h3, here q3, so h1, h2. What is h1, h2 is r. What is h1, h3? So here we have r into r sin theta, right? Because h1, h3, this is h1, h2, this is h2, h3. Okay, so h1 is 1 and h3 is r sin theta. So we need only 1 r. Okay, so this is all about. That is 1 by r square sin theta. I can multiply dou by dou r square sin theta v1 plus that is dou by dou theta r sin theta v2. Okay, so this is common, r sin theta v2 plus dou by dou phi of r v3. Okay, so when I am multiplying these two in, I can write the sin theta and sin theta cancel. With respect to r, sin theta is a constant, so I have the first term is 1 by r square dou by dou r of r square v1. Okay, this is the first term, and this sin theta with respect to theta, this will exist. This r I can take out, so this r, that is 1 by r, this sin theta on differentiate. Okay, 1 by r sin theta into dou by dou theta sin theta v2. Okay, plus again 1 by r square sin theta, that is 1 by r sin theta into this r I can take out and cancel with this, that is 1 by r sin theta into dou by dou phi of what I can write, that is r v3. So this is the final expression for the divergence. Okay, divergence of a vector v. Okay, so let us check the answer. So this is the expression for div v. Okay, so that I have given here, so you can check, that is 1 by r sin theta dou by dou phi of this v phi. Okay, so we need not write here r and r we cancelled. Okay, so you can cancel this, right? Okay, so dou phi of v3, and here also this r we cancelled, so there is no r2, there is no r, so sin theta v2, right? So that is v2 means v theta, component of theta. Okay, so that is v2 sin theta, that is 1 by r sin theta. Here you can see 1 by r square dou by dou r of r square v1. Okay, v1 means component of r. Okay, so this is all about a div. Okay, expression for div. So similarly you can represent by knowing h1, h2, h3 and q1, q2, q3 by putting the values in the general expression. You can represent divergence, gradient, curl and Laplacian in spherical and cylindrical polar coordinates. Okay, so here I have given how to represent cylindrical coordinate also. Okay, so that way we can represent. Okay, so that is the method. Now let us have some problem. Okay, see, find the gradient of a field f is equal to rho sin phi minus z cos phi in cylindrical coordinate. Okay, in cylindrical coordinate gradient is rho cap dou by dou rho f. Okay, the function is f is given here, so I substituted it, and 1 by rho phi cap dou by dou phi of rho sin phi, this, that is f is given here, that I substituted it, and z cap dou by dou z f, that is f I am substituting here. So plug in the del f div gradient in cylindrical coordinate equation. I have substituted cylindrical coordinate equation is this. I have substituted here, instead of r they have used the notation rho. Okay, in the question they have given instead of r the notation is rho. That's only. Okay, now you can differentiate dou by dou of, when you do this, sin phi is a constant, so sin phi only, and this term is a constant with respect to rho, so 0. So here rho cap sin phi. Okay, when you do this with respect to phi, so rho cos phi. Okay, rho cos phi here, and with respect to phi cos phi, that is minus sin phi, so minus is so plus z sin phi. Okay, now when you do with respect to z, this term is 0, and I can this is minus cos phi, so the answer is z cap minus cos phi, so that you can substitute. Okay, rho cap sin phi rho cap, and here cos phi into, if you take a rho out and cancel, here cos phi plus z by rho sin phi into that is here rho cap. There is a mistake, right? Okay, so here is the mistake. Here this is 1 by rho phi cap. So here this second term is, here we have phi cap. Okay, so that we can change. So here phi cap, here it is. So here it is phi cap. Okay, so this is the change. Now z cap, so rho cap, phi cap and z cap. Okay, so here z cap into minus cos phi. When you do this, minus cos phi. Okay, so minus cos phi z cap. So this is the answer. Now let us go to the another problem. Find the gradient of the scalar function f of r theta is equal to r cos theta sin square in spherical polar coordinate. In spherical polar coordinate, gradient is r cap dou by dou r 1 by r theta cap dou by dou theta. So okay, here there is no phi term, so we need not write the third term. Okay, so here only r and theta is variable, so the phi component I can take as, in spherical polar coordinate we have three coordinates r, theta and phi. Here the absence, this phi component is absent. Okay, so that term we can cancel. So you can plug in this function value here, that is r cap dou by dou r. When you differentiate with respect to r, I have cos theta here. Okay, with respect to r, sin square theta is 0. Cos theta taken out, and when you do r, that is 1. Here theta cap by r into, with respect to theta, cos theta on doing minus sin theta. Okay, so minus r sin theta here, sin square theta on doing 2 sin theta into sin theta on doing cos theta. Okay, so when simplify you will get like this. Okay, let us do another problem. Find the divergence and curl of the vector field f of r theta is equal to r cos theta r cap plus sin theta theta cap. Okay, so from the question it is clear that this is the VR component and this is V theta component, and we can write the general expression for divergence, that is 1 by h1 h2 h3 into dou by dou r of h2 h3 into, that is h2 h3 into and VR. Okay, that is VR plus dou by dou theta into, that is h1 h3 into V theta. And the next term I am not writing because dou by dou phi, there is no phi component here, so we need not write that. Okay, so I can substitute in spherical polar coordinate, h1 is equal to 1, h2 is equal to r, h3 is equal to r sin theta. Right, when I am substituting this, I can h1 into h2 into h3, that is 1 by r square sin theta into dou by dou r of, what is h2 h3, that is r square sin theta into, what is VR, VR is equal to r cos theta into r cos theta plus dou by dou theta into h1 h3, that is r sin theta into, what is V theta, that is sin theta. Okay, so when I am doing this, I can take here 1 r, here r square, that is r cube, sin theta cos theta I can take out. Okay, so I can do this here. Okay, or let me go to blackboard. Okay, so here we can this 1 by r square sin theta into r square sin theta cos theta I can take out, sin theta cos theta into, here we have r square into r cube, with respect to r when I am differentiating, that is 3r square, and here we have the r sin theta sin theta, or I can take out sin square theta with respect to theta, that is 2 sin theta into cos theta. Okay, so when I am multiplying these two in, then r square cancel, sin theta cancel, I have 3 cos theta here, and this sin theta cancel, this r square and r cancel, so we have 1 by r here. 2 sin theta cos theta is sin 2 theta, so answer is 3 cos theta plus sin 2 theta by, also we have r sin theta also here, sin 2 theta by this r square sin theta, that we can cancel with this r, so we have an r sin theta. Okay, so this is the answer. So let me go to the main screen. So that is 3 cos theta plus sin 2 theta divided by r sin theta. Yes. Now we can find out the curl, right? Del cross f is equal to, this is the expression for curl. Okay, in terms of spherical polar coordinate, that is 1 by r square sin theta into r cap, r theta cap, r sin theta phi cap. Okay, dou by dou r, dou by dou theta, dou by dou phi, and here vr, here v theta, here v phi. What is vr? Vr is r cos theta, r cap component, and what is v theta? Theta component is, theta cap component is sin theta, and there is no phi component here, so I can take this as 0. Okay, now just expand the determinant. Okay, so again take the r cap out, that is r cap into dou by dou theta of 0, that is 0, minus dou by dou phi of sin theta, that also 0, minus r theta cap into dou by dou r of 0, again 0, and dou by dou phi of r cos theta, that also 0 because there is no phi variable here, plus r sin theta phi cap into this dou r of sin, dou by dou r of sin theta, that is 0, no variable of r here, minus dou by dou theta of r cos theta, that we can minus of minus r sin theta, that is plus r sin theta. Okay, so this I can write as r square sin square theta phi cap. Okay, so this is the result, and also I forgot to put the outside the bracket, we have 1 by r square sin theta. Okay, that also we have to add, so 1 by r square sin theta, so this r square r cancel, right? So this is 1 by r square sin theta, here also we have r square sin square theta phi cap. Okay, so r square and r square cancel, and here we have sin theta, so the final answer is sin theta phi cap. Okay, so this is the last problem today, and in the next session we will discuss about the Jacobians. Okay, thank you.